Think about cooking. When you mix ingredient to make a cake, the final cake come from the same ingredient. You didn't create the new matter. You just change its form. Or what we can say, it's like when children building something with the Lego bricks, you can take apart one structure and build a new one using the same pieces. Tell me, did the number of Lego pieces change? No, right. You just rearrange them. In chemistry, something very similar happens. Substances don't disappear or appear magically, they simply rearrange. So, hello everyone, welcome back to my science diary. Today, we are going to learn about an important scientific principle called law of conservation of mass. Before we begin, let me ask you something. Have you ever seen something disappear, like sugar in water or paper when it burns? Do you think it's really gone? Many people think matters disappear, but in science we know that's not true. Let's find out why. And this brings us to the law of conservation of mass, which is given by the Antoine Lavoisier. It states that the mass can neither be created nor destroyed in a chemical reaction. The law of conservation of mass states that the mass can neither be created nor destroyed in a closed system. This means that the total mass of substance before a reaction is always equal to the total mass after the reaction. Well, let's understand this even better. Like we saw in our last lecture, the Faraban the magnesium ribbon and noticed the mass of product was greater because the oxygen from the air combined with magnesium. And then Halim repeat the same experiment carefully and weighing all the substance before and after the experiment and confirm that the total mass stayed constant, just like the Lavoisier law states. Let's try to understand this with simple example. Just imagine we carry out an experiment where the element A it reacts with the element B to give the compound C, where element A and B seems to disappear. They actually combine to form C. Nothing is lost. Everything is still there in a new form. Now that we understand the law of conservation of mass, let's see how to calculate it. Let's solve a quick problem together. If we react 6 gram of magnesium with 4 gram of oxygen, what will be the mass of magnesium oxide formed? What we do, we simply add 6 plus 4 equal to 10 gram. So the product will be the 10 gram. So this is how we can calculate the mass. Now you tell me what will happen if the reaction takes place in an open container. Yes, some gas may escape, so it might look like mass is lost, but actually it's not. So to conclude, the mass is always conserved. It's never disappeared. It only changes the form. This is a fundamental law in chemistry and that helps us understand all the chemical reactions. Let's see some more numerical problem based on law of conservation of mass along with their answer. Like the problem is like the halin react 10 gram of vinegar with 5 gram of baking soda in a closed container. What will be the total mass after the reaction? So for solving this, what we do, the total mass before is 10 gram plus 5 gram equal to 15 gram. So the total mass after the reaction will remain the same as before the reaction is 15 gram. Let's look on another example like missing mass problem. In a chemical reactions like 8 gram of oxygen react with the carbon to form 22 gram of carbon dioxide. So what is the mass of carbon used here? So for solving this, what we do, so it's like in an open system like burning carbon dioxide openly. Some mass escapes as gas. So to calculate that missing mass, you would measure the initial mass of reactant like the substance burning plus oxygen. Then measure the mass of solid residue like ash. The difference is the mass of the gas that floated away. And um, you can explain if you weigh a log before you burn it and then the weigh the ash afterwards, the ash weigh less. But that's because the invisible gas made by the fire floated away into the air. If you could catch all those gases and weigh them too, the total mass would be the same as the log you started with. So no, we know there were 22 gram of carbon dioxide made, and that 8 gram that was oxygen. So to find the missing mass of carbon, we just subtract them. So 22 gram minus 8 gram equals 14 gram. Let's look at another example like Harlan burns 6 gram of magnesium in 4 gram of oxygen. What is the mass of magnesium oxide formed? So for solving this, what we do, we just simply add them. Total mass before 6 plus 4 equals to 10 gram. So mass of the product is 10 gram. So we have seen that the last conservation of mass is a fundamental principle that helps us understand every chemical reaction, whether we are baking a cake, mixing vinegar and baking soda, or even looking up at stars. The total mass always stay constant. Keep practicing this example and you will see how everything fits together. Thank you for watching. I will see you in the next video.